Hello everyone. Today I will describe the various multiple access techniques TDMA, FDMA, CDMA and OFDMA. Before talking about the multiple access techniques, let us try to understand the difference between multiplexing and multiple access. Now let us look at what is multiplexing. So you have multiple low rate data lines. You use a device called multiplexer, or we call it as MUX. So this MUX will be controlled through the status lines to allow one link from these multiple lines to send its data onto this high rate link. This is a single communication link, and this is a high rate link. And a demux or demultiplexer will be controlled through these status lines to establish the connection between one of the multiple lines at the input of the mux and one of the lines at the output of the demultiplexer. So there is a point-to-point link that will be established between the transmitter and the receiver. These multiple lines are the input data lines, and these are low rate lines. So this single link in between the mux and demux will be a high rate link. It can be a backhaul or a fiber optic cable, which will carry the high rate data through this link. Now, two different techniques can be used to do the multiplexing. One is known as time division multiplexing. The other is known as the frequency division multiplexing. In case of time division multiplexing, what you can do is you can send the data through these lines quickly, so that a time slot which is allocated during which the communication is to be done, so that time slot can be used to transmit, can be used by these multiple data lines to transmit in that time slot only. That means the full time can be divided into slots, and each slot can be allocated to different users at different times, right? So that is known as time division multiplexing. The users that will send the data will be sending the data at a certain higher rate, so that the user will use less amount of time, and the other users can be accommodated in the specified time period in which the communication is possible during that time period. So that means time period will be divided into time slots, and each time slot will be allocated to different users. So this is time division multiplexing. Now the point is that we will be sending the data at a higher rate, so that each user can send data at faster rate, and other users can also be accommodated. But in the frequency division multiplexing, the every user will have a certain frequency allocated, and on that frequencies the input will be superimposed, and every user will be allocated a different frequency, so that when the signals are transmitted by different users at the receiver side, the frequencies can be tuned on which they were superimposed, and you can separate out the data lines based on the frequency division multiplexing, right? So in TDM, we are using the time as a multiplexing parameter, and in the case of frequency division multiplexing, we are using frequency as a parameter. But this is of course a point-to-point link communication. Now let us look in detail what is multiple access. Now in this case, in this multiple access case, you don't have a single device, rather you have multiple devices which are trying to communicate through the you have multiple mobile devices which are trying to communicate through this base station tower. Now these are mobiles, these devices are mobile devices trying to access the channel between the mobile and the tower. So there is every device is trying to access the channel So that means multiple devices are there which are trying to access the channel. So that's why this is multiple access. Now there can be various techniques which are used so that these devices can be given access to the channel. And these techniques are TDMA, FDMA, and CDMA. And these lines are of course low rate signals which these devices will transmit bit stream which is of lower rate as compared to the bandwidth of the channel. And there requires a kind of coordination so that the multiple devices can one by one get the access to the channel, right? Some kind of coordination is required so that proper access can be given to these mobile devices. Now, how the coordination will be done? That is, first type of coordination is time division multiple access. The second is frequency division multiple access, and the third is code division multiple access. Now, in these three types of multiple access techniques are coordinated way of coordinated way of giving the access of the mobile devices to the channel. So therefore, there will be minimum interference uh, because of this coordination. Now in TDMA, what we will use is we will try to send the data from each mobile device faster so that these devices can use the channel in some time slots. So the whole um, excess period will be divided into time slots, and each time slot is allocated to these devices. So this is time division multiple access. Frequency division multiple accesses, every mobile device will be superimposing its digital data onto a certain frequency, and that frequency will be, and that signal, superimposed signal, is then transmitted through the channel. So this is the, and this is the first user, second user. I mean, this is how the frequency division multiple access will be done. In CDMA, we use codes to differentiate between the different users, right? And there is one more technique which can be used to access the channel, which is CSMA, carrier sense multiple access. This is an uncoordinated way of giving the access to the mobile to the device. This is an uncoordinated way, and this is particularly used for Wi-Fi. And these coordinated schemes are used for the cellular communication. Now, since this is an uncoordinated way of giving the access, so therefore, this CSMA is more prone to interference. Now let us look at FDMA first in detail. Now this particular waveform is for one user, and I am representing ones and zeros using the Gaussian pulses. So this Gaussian pulse is representing 1, this is again 1, and this negative polarity of the Gaussian pulse, this is actually representing 0, or or it is -1. And this bracket is there to indicate that there are multiple users which are having this kind of data representation, right? Now one particular user will be multiplied with a carrier frequency which is f1, right? And the second user can be multiplied with a carrier frequency f2. But let us look at the first user first. So first user is having this digital bit stream represented using the Gaussian pulses. It is multiplied with the carrier f1. So when the high frequency carrier is multiplied by this waveform, if you take the Fourier transform, the spectrum, these pulses will be centered at f1 and minus f1. So this is the frequency spectrum that we will obtain after taking the Fourier transform when you multiply the carrier frequency with these Gaussian pulses. Similarly, we will be multiplying the second user with another frequency, higher frequency carrier. So we will also get the same pulses, centered around f2 and minus f2. This is how the whole bandwidth will be. We will be using certain frequencies from the bandwidth, and we will be superimposing these Gaussian pulses of the specific users onto the carrier frequencies. Right, so this is the Fourier spectrum. This is the frequency spectrum once you take the Fourier transform. The important point to note here is that there must be a guard band between the two users, so that the users are separated in frequency, so that the interference is avoided between the users. So a guard band is required in the frequency domain. Now, if you look at the time division multiple access, so these are the representation of the users. So we will be sending these pulses faster. So this we are taking less time to send for user one, right? So next time slot that time slot will be used by second user. So that means we will be sending the digital bit streams of different users at a faster rate, right? So that less time can be consumed by one user and the rest of the time slots can be used by the other users. But important thing to remember to note here is that there requires a certain guard time between the two users. That is, so guard band in time domain. So time division multiple access requires guard band in time domain, whereas the frequency division multiple access requires guard band in the frequency domain. So these in TDMA, these pulses are multiplied by the same carrier, whereas in FDMA they were multiplied by different carriers, right? And every user was sending at all the times. But in time division multiplexing, we are multiplying with the same carrier, but every user is using a different time slot. So because these are high rate signals, so once you multiply with the high frequency carrier wave and you take its Fourier transform, there will be expanded version of because the spectrum will be centered around f and minus f. So f is the frequency of the carrier that we are using, and this will be little broadened version of the spectrum, because these are all high rate signals. Once you multiply it with the carrier frequency, you will get a spectrum which is centered around f and minus f on the negative side, but the width of the spectrum will be more, right? Since you are sending more quickly, so usage of more frequency bandwidth will be there. Now users send data quicker so that the rest of the time other users can send the data. So this type of multiple access, the FDMA and the TDMA, was used in 2G mobile system, which is GSM. Okay, let us look at the pros and cons of the FDMA and TDMA now. Equalization is more difficult in TDMA than in FDMA. So what is equalization? In case of, let's say, you are dealing with a multipath communication, since the multipath is the time delay between the two paths, because one user, because these pulses are of wider time, so the delay between the two paths has to be very large to affect these particular pulses in case of FDMA. So equalization is easy in frequency division multiple access, whereas in TDMA, since the time slot allocated to one user is shorter because we are sending at a higher rate, so TDMA is more prone. The equalization to be done in TDMA is a little more difficult, because in multipath propagation the signals can be affected in TDMA in case of time division multiple access. So that is what I'm trying to explain here, because in multipath propagation, since signals are being sent in shorter time intervals, therefore the different signal path will affect the signal more prominently in case of TDMA. In FDMA, the multipath should have significantly larger time difference between paths to affect the signal, right? So this is the difference between the equalization is more difficult in TDMA than in FDMA. Now let us look at CDMA, code division multiple access. So in CDMA, so this is user one data, and these brackets I am drawing here these brackets to show that there are multiple users sending this kind of data. Ones and zeros are represented by these Gaussian pulses. Now in code division multiple access, the users will be sending at all the times, and uh, at all the times they will be sending. So but the users will be multiplied with the different code, and they will be multiplied by a single carrier frequency. Users will be sending at all the times, and you will be using one carrier frequency to multiply the bit stream. But here you will be using certain codes are embedded into the into the multiplication of the carrier and the data. So these codes are different for different users. So code for user 1, code for user 2, and there will be different codes for different users, right? So, and these are high rate codes, and we call these as the chips. So therefore the chip rate is very high actually. So once you multiply the data pulses with the chips and the carrier frequency, so once you try to take the Fourier transform and try to see the spectrum obtained in the frequency domain, you will see that the spectra, since these are high rate chips, so you will get a spectrum centered around f and minus f on the negative side, but a broadened version of the spectrum, right? As was the case in the TDMA. So symbols are not sent too fast. Here the point is that how it is different from TDMA. In TDMA, the symbols were being sent at a faster rate. Now the symbols are being sent at not so fast. That's number one difference between CDMA and TDMA. So these brackets are showing the collection of signals for different users. Multiply by digital codes we call as chips, and chip rate is much higher as I have just explained. And the most important point is that the codes are orthogonal to each other, and we get a wider spectrum at the output. So therefore the spectrum is actually spread. So that is why this technique is also known as spread spectrum technique. Now let us look at the FDMA, TDMA and CDMA, the basic difference. In FDMA, users uses in FDMA, users use some of the frequency and all of the time. What is the meaning of what is the meaning here? User 1 uses different frequency, user 2 uses different frequencies, but for all the time they are sending the data. User 1 is using, let's say, F1, user 2 is using at F2, but they are sending, but they are using, they are trying to, they will access the channel at all the times. In case of TDMA, all the frequency, the complete frequency range will be used to for all the users, but every user will be sending at different times. So all the users will use the same frequency to transmit to be for the data to be superimposed upon, but they will be sending their data at different times. In CDMA, all the frequency, the frequency is used for all the complete bandwidth, complete range is available to all the users, and the users are also sending for all the complete time. They are not time for access is not divided into slots. The complete time all the users are sending over the complete frequency range, and they are using the complete time of the channel access. But how they are differentiated, they will be separated by different codes, right? So that is why this is known as code division multiple access. And also important thing is that no guard band in CDMA, which is good thing, but we have to worry about codes being orthogonal to each other. In case of CDMA, there is no guard band required, as was the case in FDMA. We require guard band in the frequency domain. In the case of TDMA, we require guard time in the time domain, right? But no such requirement is there in CDMA. But since the codes need to be orthogonal to each other, which is a challenge to fulfill. In multipath, chip rate is higher, and so chips can be affected by multipaths. Since chip rate is very high, so that means the chips can be affected by multipath propagation. So if the delay is not very large between different paths, so that delay, that multipath propagation can affect the performance of the CDMA system, because the chip rate is also very high. We use the rake receiver where the correlators are used to correlate to each of the different multipath, but still it is a challenge in CDMA to obtain the orthogonal codes and to handle the multipath propagation. Now, CDMA is a 2G mobile system or a 2.5 mobile system, which is an American standard 2G mobile IS-95, whereas GSM is also 2G, but it's a European standard. Now, let us look at what is OFDMA, which is orthogonal frequency division multiple access. Now, what is OFDM? OFDM is a basic modulation technique, which is orthogonal frequency division multiplexing. Now, it takes symbols. It takes symbols, which are the digital data, and put them in vector form. So the symbols are taken and the symbols are put in vector form x1, x2, x3, and so on. And then these symbols, this is particularly for done by one user. And this bracket here shows that the same process is done for by different users, right? So a user converts these symbols into a vector form x1, x2, x3, and so on, and you take the IDFT, and you will get the output of the IDFT, which is a time domain signal, and it contains the information of all the frequency component which is present in the data. And many users are doing this type of same process, where every user will be for every user the symbols will be converted to vector form, and then IDFT is taken and we get a time domain kind of signal, right? So that's why this is known as orthogonal frequency division multiple access. Now, these are the many users are doing this. So what we do is, how do we give the access to different users? Now, since the symbols are converted to vector form, so some of the elements of the vector we will make 0, and we will try to adjust other users into those slots. So if I take the case here, so if this is the rectangular representation of the symbols, then the Fourier, if you take the Fourier transform in the frequency domain, it will be sync pulses. So these sync pulses, black sync pulses are for user 1. These red sync pulses are the pulses where the pulses for the user 1 have been made 0, and we are using those sub channels for adjusting the second user. So these are the sub channels for user 1. These are the sub channels for user 2. In frequency domain, you select some of the to be 0, some of these points to be 0, where you will place the other user signals. That's what I will try to explain here. So if the oscillators, now what is the point? Now the point is that the it is very difficult because there is no guard band here. So even the pulses are overlapping with each other. So why it is possible? These have been made possible because of the high quality algorithms used for carrier synchronization. So these are you require carrier frequencies to superimpose your data onto these carrier frequencies. And how the carrier frequencies will be generated? They will be generated through oscillators. Now, good quality oscillators and algorithms are used for carrier synchronization, and which have made this possible to transmit data without the guard bands. Now, if the oscillator which generates carrier frequencies are more accurate, then we can get rid of the guard band. So OFDMA was used in 3G and 4G systems. Now let us look at the advantages and disadvantages of OFDMA system. Now everyone sends all of the time, as was in CDMA. So every user is sending at all the times, as was the case in CDMA. No guard band is required. They don't use all the frequencies all the time, but they use different components of the frequency band, and you can intersperse and decide which ones are to be allocated to different users. But here the difficulty is that you need very accurate synchronization. So equalization is easy, right? Advent of FFT chips made it possible to achieve this OFDMA system. Very flexible resource allocation, but the disadvantage is that you have to pay the penalty for cyclic prefix. Very flexible resource allocation means the where you will place the subcarriers, so that is your choice. So you can place the subcarriers with a flexible in a very flexible way, but there is a penalty to be paid, and that penalty is of cyclic prefix. In case of OFDM, the cyclic prefix problem is will be there. So I'm not dealing with OFDM, but this is the OFDMA system by which the multiple users will get access to the channel. Thank you very much. I finish my lecture here.